Exponential and logarithmic function. First we'll look at the exponential function. F of x equals a to the x power, where a is greater than 0. In other words, a cannot be a negative number. So if we look at this, what makes this special compared to the other functions we've dealt with so far? And the one difference is that x is in the exponent. The unknown is in the exponent. So we're going to study how that affects the function's value and what properties it may have, different from regular functions. And we're also going to study the logarithmic function. F of x equals the log of x to the base b. Now the logarithmic function is an invention. We invented that from the exponential function. We changed the form. One way to look at this is the logarithmic function is a foreign language and the exponential function is your current language. So you can understand things in the exponential function form and not so well in the logarithmic function unless you speak that language a lot. So we never get that much practice at it, so we're always going to kind of transfer back to the exponential when we want to decide what we really have. And we'll see that relationship a little later. A special exponential function is when we replace a with e. Now e is a number we discovered, like pi, and so it's a natural occurring number. So f of x equals e to the x is a special exponential function. It's just like the one above, but there isn't an a there. It can't be any number. It's got to be e. A special logarithmic function that directly relates to the special exponential function is f of x equals ln of x. Now what that is equivalent to is f of x equals the log of x to the base e. There's that e again, but we're using it as the base instead of the b and the one above it. So we've got e down there. And when you have an e as the base, you don't write log, you write ln. ln of x, so it's a natural log of x. A special form that's different from ln of x is f of x equals the log of x. Now there's no base at all in this one either, so we have to decide what does that mean. And what we've done is, if it's the base 10, we just won't write 10 down there. And this is because our whole number system is to base 10. That's what makes this a special one. So this is equivalent to f of x equals the log of x to the base 10. So there's our 5 cases that we're going to be dealing with, and we're going to show how we solve equations that contain these and also how they're useful in solving other problems. It is important that you understand the relationship between the exponential function and the logarithmic function. It is easy to understand the exponential function, but the logarithmic function is defined in terms of the exponential function, as can be seen below. So once again, logarithmic function is a foreign language, exponential function is your current language. So y equals a to the x is equivalent to x equals log of y to the base a. There's our relationship. So let's go on the left again. Y equals a to the x. Now that should make sense to us. We got y equals a number raised to an exponent, but the exponent is a variable. It can change. So how does that relate to the log? If you look where the a went, the a is the thing being raised to the power, and a is the base of the log. It's a little a down there. The exponent is by itself in the log. X equals the log of y to a, and y is the result. So if you take a and raise it to the x power, you get y. And that's what you got to look when you see both of those. They both mean exactly the same thing. So you have to make that comparison. Another way to look at it is the log of y to the base a is really an exponent, isn't it? See, the log of y to the base a is equal to x. But x was the exponent. So that sort of makes log of y to the base a an exponent. And we're going to see how that translates out a little bit later. But let's first look at 3 examples. Examples: find x where 1. The log of x to the base 2 equals 3. 2. ln of x equals 5. And 3. The log of 100 equals x. So let's find the x in each one of those cases. But those are all written in the foreign language form, so we're going to transfer them over by our equivalent expressions just above, and then find out what x is. So in the first one, we have x is equal to 2 cubed. Let's see how we found that. The base of the log was 2, so that's going to be the thing being raised to a power. The 3 is the exponent, and the x is the result. So x equals 2 cubed, or in other words, 8. Now the natural log. Since there's an e to the base, we're going to have e on the right-hand side there raised to the 5th power, and that's going to equal x. So x equals e to the 5th power. And you can use your calculator to determine what that is. Okay, the third case, we've got the log of 100. Now we want to convert that over, so we're going to convert it as 10, because remember there's a 10 down there. 10 to the x equals 100. So what does x have to be? That implies that x has to equal 2.